Hey girls, I'm going to talk you through the very basics of quadratic functions just to get you started. So quadratic functions work in and look like y equals ax squared plus bx plus c. So that's this, right? Where the a represents the letter that's in front of the x squared, in this case it's a 1, b represents the number in front of the x, and c represents the other number that has an x to the power of 0, right? But is not, in this case, not present, but could be present. So we could have a -3 as an example, right? So for this particular function, and this is a quadratic function, a equals 1, b equals 2, and c equals -3, all right? But notice how initially it doesn't matter if you have that's still a function, because in this case, a and b are the same, but in this case, c equals 0 because there is no added number there, okay? Next, look at this one. Y equals x cubed plus x squared minus 4x minus 9. Because this has a cube, this is not a function. And I use capital F lowercase n to say function, okay? Not a function. It's got to be in this form. Notice there is no x cubed here, all right? So let's keep going and talk about what you can do with this and what actual initial solving can look like. Primarily it's about after you say whether something's a quadratic, identifying then a, b, and c, right? A, b, and c, in this case the 0. At the same time, we can also say what is y for a function. So you can start with a function that's y equals, say, 2x squared minus 3x plus 4. And if I tell you that x equals 2 and ask what is y, it's a pure substitution. This is an evaluation. Evaluate means you take this x plus equals 2, and that positive 2 gets substituted in everywhere you see x, like so. In which case, we're going to get 8 minus 6 plus 4. Thus, if we simplify that, we know that x equals 6. Pardon me, y equals 6. Goofball. Okay, so that's part 2. Now, part 3. Here we go. Let's keep adding on. All right. Lastly, you can be asked, just in the initial basics, if you're given a function, so let's say it's y equals, you could have a negative squared in this case, right? This is realistic because all we're going to do is evaluate. And you can be asked, is the point a, which is say 2 comma -8, on the line of this function? If we graph this function is 2 comma -8, is the point A on the function? Well, you're given an x and a y. So all you have to do is substitute these in and see if you get a true statement. All right? So I'm going to substitute in my y, which is -8, equals -1 times x squared, so 2 squared, minus 3 times 2 plus 2. And I come up with a true statement of -8 equals -8. True, therefore the answer is yes, a lies on the function. And we can write out the full function, but that's just shorthand for you, okay? Suppose we have the same function, and again we're asked, does this point satisfy the function? That's another way the question would be phrased. Does the letter b, the point b, which is at -3 comma 4, satisfy the function y equals -x squared minus 3x plus 2? Again, substitute in. So we have 4 equals negative, and it's -3 squared. Watch your signs. And you'll notice as we solve this, I'm going to end up with 4 as my y, and the result of evaluating on the right side with x, I get 4 equals 2, which is so not a true statement, right? So no, b is not on the line. Does not satisfy the function y equals -x squared minus 3x plus 2. So you can now tackle exercise 19a, page 386. Check your unit plan for the assigned problems, and I'll see you in class.